Trigonometric functions in any angle. First example, we're asked to determine the quadrant in which theta lies. We're told that the sine of theta is negative and the cosine of theta is negative in this quadrant. So let's picture our coordinate plane and the signs of our trig functions in the various quadrants. In quadrant 1, all of the functions are positive. Quadrant 2, the sine and its reciprocal, the cosecant, are positive. In quadrant 3, the tangent is positive, and in quadrant 4, the cosine is positive. And so what we do sometimes is we try to have memory devices to help us remember this. Some people start with the phrase, all students take calculus. They're in the top right quadrant, quadrant 1, and then they just go counterclockwise around. Quadrant 2, 3, and 4, all students take calculus. So we know for this particular problem that the sine of theta is less than 0. So that has to be the bottom 2 quadrants. But we're also told the cosine of theta is less than 0. So that's these 2 quadrants. So we can see in quadrant 3, both the sine and cosine are negative. So therefore, theta lies in quadrant 3. We'll do another example like this. Here we're told the cosine of theta is positive and the tangent of theta is negative. So all students take calculus to help us remember this. And I know if the cosine is positive, that has to be these 2 quadrants. For the tangent to be negative, it has to be these 2 quadrants. Therefore, quadrant 4 is where the cosine is positive and the tangent is negative. In this problem, we're asked to find the values of the 6 trig ratios of theta using the functional value and constraint. All right, so the value that's given is the sine of theta. This angle theta is 3/4, and we know that theta lies in quadrant 2. Well, let's start with the sine of theta being positive. It's only positive in these 2 quadrants, but we're told expressly that theta lies in quadrant 2. So let's consider a right triangle. There's our theta. Remember, SOHCAHTOA is a nice way to remember the ratios of the trig functions. We're told the sine of theta is 3/5, so opposite over hypotenuse. This happens to be a 3, 4, 5 right triangle. How nice, so I can just know that the missing side length is 4. Otherwise, I could have used Pythagorean theorem to get the missing side length. All right, so now let's start with our 6 trig ratios. We know the sine of theta is positive. It's been given as 3/5. The cosine of theta, adjacent over hypotenuse, is typically 4/5, but in this quadrant, it's negative. The tangent of theta, which is opposite over adjacent, 3/4, in this quadrant will be negative. Now let's do the reciprocal functions. The reciprocal of the sine is the cosecant, and we'll keep the positive sign. The reciprocal of cosine is secant, and the secant of theta is negative 5/4 here in this quadrant. The reciprocal of tangent is cotangent of theta, which equals negative 4/3. And we'll do one more example like that. We're told the cotangent of theta is negative. We're told the cosine of theta is positive. So which quadrant is this? Where the cotangent is negative and the cosine is positive. So this one has to be quadrant 4, right? All right, so here's our right triangle. Here's SOHCAHTOA. Cotangent is adjacent over opposite. So we'll put 3/1. Using the Pythagorean theorem, a squared plus b squared equals c squared equals 10, so the hypotenuse is the square root of 10. Now we can write down our values for the 6 trig functions. Sine of theta in quadrant 4, it's negative. Opposite over hypotenuse, -1 over the square root of 10. We'll have to rationalize that in just a minute. The cosine of theta, adjacent over hypotenuse is positive in this quadrant. The tangent of theta, opposite over adjacent, in this quadrant will be negative. The cosecant of theta will be the reciprocal of the sine, and it's still going to be negative. The secant of theta, the reciprocal of the cosine. And the cotangent of theta, which is the reciprocal of the tangent. All right, now the only thing we have left to do is to rationalize our denominators for sine and cosine. So here's how we do that. We multiply by a disguised form of the number 1. Now we no longer have a radical in the denominator, so the precise answer for the sine of theta is negative root 10 over 10. Let's take our cosine. Let's rationalize the denominator and rewrite our cosine as 3 root 10 over 10.